In this video, we're going to continue on with major depressive disorder, and we're going to talk about antidepressants, in particular how antidepressants alter brain chemistry, and we're going to start off with monoamine oxidase inhibitor. So there are different categories of antidepressant drugs that we're going to discuss. The first one in this video are monoamine oxidase inhibitors. In another video, we'll discuss reuptake inhibitors, and then in a third video, we'll discuss some atypical antidepressants, and then some other drugs that are up and coming in the treatment of depression. Now, if you think back to chapter 2, I said it was very important to understand some of the things we were talking about in terms of how neurotransmitters work, how they're broken down, and those types of things. And so I tried to emphasize that there was two main ways. Once that neurotransmitter was released, so remember we have our presynaptic terminal, we have our postsynaptic terminal, we have receptors here, we have our synaptic vesicles, and then that neurotransmitter is released into that synaptic cleft, and it binds that receptor. And we talked mainly about those ionotropic receptors where an ion flows in. Well, once that neurotransmitter is done doing its job, it has to be broken down in some way. So that if it's not broken down, it's going to stay here in that synapse and keep binding those receptors. So one thing we talked about were these reuptake transporters. And so these reuptake inhibitors, what they do is they block these reuptake transporters, thus keeping neurotransmitter in the synapse for longer. So if more neurotransmitter is being released, that's going to increase the amount of that neurotransmitter. Even if it doesn't, if that neurotransmitter is there, it's going to bind those receptors and have an effect for a longer period of time. So those are the reuptake inhibitors that we'll discuss in another video. We also sometimes have this enzyme, or have this neurotransmitter, and it's broken down via an enzyme into two inactive components. So together this would make a nice little circle, but as two inactive components, it can't function. So this sometimes happens in a glial cell, or sometimes the neurotransmitter is taken back up and then broken down inside the presynaptic terminal. And so that's what a monoamine oxidase inhibitor does, is it stops this breakdown process. So the enzyme that typically would break down the neurotransmitter is monoamine oxidase, and monoamine oxidase inhibitors are going to inhibit that process. So monoamine oxidase inhibitor, like I tried to show you on the previous slide, it blocks the enzyme monoamine oxidase. So monoamine oxidase, so this MAO stands for monoamine oxidase, metabolizes catecholamines and serotonin, so those were our monoamines, into inactive forms. So remember, our catecholamines were dopamine, norepinephrine, and epinephrine. Serotonin added to that makes those all monoamines, and so that's why they're monoamines, and they're going to be oxidized. So here's a better diagram showing you what I drew. Here again is our presynaptic neuron. Here's our presynaptic neuron, just showing you how dopamine is synthesized from tyrosine in our diet. L-dopa we talked about is that precursor that we give to people with Parkinson's disease to increase their levels of dopamine. Dopamine can then be transformed into norepinephrine. Now here's monoamine oxidase, and there's an A form and a B form. And here we see it in the presynaptic terminal. Here we see it in the blood, a blood vessel. It also can be in, like I said, astrocytes, I believe, have one form of monoamine oxidase. And so the idea is that that's going to break down these monoamines into inactive components. This monoamine oxidase inhibitor, so MAOI, blocks that. And by doing that, it increases the level of the monoamines. So here we have, just showing you again, serotonin broken down by monoamine oxidase into inactive forms. We have norepinephrine broken down by monoamine oxidase into inactive forms, which is two that I chose to show you. So the result is more neurotransmitter in the presynaptic terminal available for release. And some examples are Marplan, Nardil, MSAM, Parnate. Those are all probably drugs you've seen, heard about on different commercials. There's all sorts of commercials for antidepressants. And then it's important to understand, though, that there are side effects. So all of these different drugs have side effects. One of them is high blood pressure that results with certain foods. Now, because you're blocking the breakdown of neurotransmitters, those precursors that we get some through our diet and some are naturally occurring, they're going to increase because they're not needed to make new neurotransmitter. So certain foods can, if you eat certain foods, that can raise your blood pressure. A lot of it is things like aged cheeses, cured meats, soy sauce, improperly stored foods or spoiled foods, which hopefully you're not eating anyways, bean pods. So it's careful to, if you're taking one of these drugs, you need to make sure that your diet is regulated. And now hopefully you've downloaded and have the drug chart printed out. And so we'll go ahead and fill out that first part of the drug chart. So the table looks something like this. So whether you, if you don't have a printer to print it out, go ahead and you can write this down on a piece of paper. I'd like you to try to fill it out as best you can by looking at the lecture notes, re-listening to what I said previously, and then we'll go over it in our Zoom session. Here's just another diagram showing you that, showing you here we have the neurotransmitter. So here we have the neurotransmitter. Monoamine oxidase breaks it down into the metabolites or inactive forms, and what monoamine oxidase inhibitors do is block this.